For more information, please visit SGMAK Associates website.
Hi, here are some more problems on quadratic equation. I think in this section we have taken problem statement and converted into a model equation that looks like quadratic equation. They all are quadratic equation. So, but here, and then we solve the quadratic equation. We know how to solve them. So in this case, let's go through this problem. So the first part is converting the problem into model. Area of a rectangle is 260 square meter. If the length is reduced by 5 meter and the width is increased by 2 meter, then we get a square. So sides become equal. Find the sides of the rectangle. So if the sides are, if the length be x and y is the width, then x times y is 260. But then we have x minus 5, if you reduce by 5 meter, equals y plus 2. Reduce length by 5 meter and width increase by 2 meter, you get a square. So that's the relation between x and y. So x is equal to y plus 7. So now you have a quadratic equation for y. Y squared plus 7y minus 260 equals 0. Roots are minus 20 and 13. 20 is inadmissible. So we're talking about the width of a rectangle. So width is 17 and length is 20 meter. Width is 13 and length is 20 meter. Minus 20, value minus 20 is discarded because the length or the width cannot be negative. Let's look at the next problem. The consecutive numbers, you got two consecutive numbers. Sum of the squares equals 761. So consecutive numbers are x and x plus 1. So x squared plus x plus 1 raised to the power 2 is 761. So you get a quadratic equation, x squared plus 2x minus 760 equals 0. And the roots are 19 and 20. You can factorize or you can solve using the quadratic equation. So roots are 19 and 20. So, well, in this case, I think next example, current speed of travel is x kilometer per hour. So time to travel is 24 kilometer to travel 24 over x. Now if the speed is increased, if the speed was 2 kilometer more, time required would have been 24 over x plus 2, would have been less. So 24 as given, if you increase the speed by 2 kilometer per hour, you take an hour less. So so you have this equation. Original time is the new time plus 1 hour, and that gives us the quadratic equation x squared plus 2x minus 48 equals 0. And so the root cannot be negative, so minus 8 is not a correct value. So 6 kilometer per hour is the correct value, the speed of travel. Okay. Typically what happens when you have a quadratic equation, you got to make judgment. One of the roots will be inadmissible. When you compare that with problem statement, you can make that judgment easily. In this case, the speed of travel cannot be negative, so we discarded x equal to minus 8. Next problem, sailor travels 9 kilometers in 1.5 hours in the direction of the water flow. So along the flow, but travels only 3 kilometers when it travels against the flow. So let the speed of the boat is traveling at a constant speed of x, appropriate unit, and speed of the current is y. So when you're getting help of the current, so you're traveling at a speed of x plus y. So 9 divided by x plus y is 1.5. x plus y is 6, and 3 divided by x minus y. I mean, your boat speed has to be more than the speed of the current, otherwise you won't travel forward. So 3 divided by x minus y is 1.5, so x minus y is 2. So values are x equal to 4 and y equal to 2. So in this case, boat is traveling at 4 km per hour and current is flowing at 2 km per hour. All right. Again, it's given two consecutive even numbers, and the sum of the square is 100. So I've taken the even numbers as 2x and 2x plus 2. So 2x squared plus 2x plus 2 raised to the power 2 is 100. So that gives you a quadratic equation as shown here, x squared plus x minus 12 equals 0. So you get the roots 3 and minus 4. So minus 4, 3 and minus 4. So if you take x value 3, then numbers are 6 and 8. If you take x as minus 4, numbers are minus 8 and minus 6. You got two solutions to this problem. Because even if you have a negative numbers, when you square and add them, you get a positive, just like with positive numbers. Okay, let's two consecutive odd numbers here. So we have them as 2x minus 1 and 2x plus 1. For any value of x, 2x is even, so 2x minus 1 will be odd. And then if you add 2, you get another odd number, next odd number, consecutive odd number. So sum of the squares, 2x minus 1 squared plus 2x plus 1 squared is 290. You get a quadratic equation is 8x squared equal to 288, x squared is 36, x is plus minus 6. So the solutions are, if you take 6, the numbers are 11 and 13. If you take minus 6, then minus 13 and minus 11. Okay, moving on. You buy a certain number of widgets, certain number of items in $420. But if you could get one more item widget, then the average price would have been $1 less. How many widgets did you buy? So let's say you bought X number of items in $420. So average price per unit is 420 over X. If you could get one more, then average price would have dropped 420 divided by X plus 1. And given the information, 420 over X minus 420 over X plus 1 is 1. That gives you quadratic x squared plus x minus 420 equals 0. So x is minus 20 and 20. Since x represents the number of items, it cannot be negative, so x20 is the correct answer. You got 4 consecutive numbers. You got to show that 4 consecutive numbers, if you square and add them, you get and then add 1 to it. Now, the problem says if you take 4 consecutive numbers and take the product of them and then add 1 to it, product of 4 consecutive numbers and then 1 added to the product gives you a perfect square. So the numbers are x, x plus 1, x plus 2, and x plus 3. The product is x raised to the power 4, 6x cubed plus 11x squared plus 6x. Then you're adding 1 to it, so you add plus 1. So this form, we can compare that by looking at the coefficient of x. It can, you can see it may conform to, if it's a perfect square, it should conform to a form x squared plus ax plus c whole thing raised to the power 2. Because the expression has x raised to the power 4, x cubed, x squared, x and constant. So if we expand that, we get x raised to the power 4, 2ax cubed plus a squared plus 2c times x squared plus 2ac times x plus c squared. Then if we compare the corresponding term, we get 2a equals 6, so a is 3. A squared plus 2c is 11. So that gives c equal to 1. And that, so a is 3, c is 1, and that matches. So 2ac is 6 and c squared is 1. So what you get is x squared plus 3x plus 1 raised to the power 2, which is a perfect square. So if you take 4 consecutive numbers, take the product of those 4 numbers, and if you add 1 to it, you get a perfect square. Okay. All right. Okay, I think there's one more problem, I think. Or maybe 2 more problems. If you have a two-digit number, is 8 less than the product of the digits. So 2-digit number, so let's say x is in the 10th place and y in 1's place. The number is 10x plus y. So the number is equal 2 times xy, product of the digit minus 8. And it says that the digit in 10th place is 1 more than the digit in 1's place. So x is y plus 1. Then if you solve this 2, you can convert into a quadratic of y. 2y squared minus 9y minus 18 equals 0. So you get values of y as you get now in this case, this is to make sure that one number is 6 for y, another number is minus 1.5. So we discard that number 1.5. We take just the positive value for x for y. So in this case, I think the values. Let's check here. X is y plus 1, so 10 times y plus 1, so y is 6 and x is 7. Yeah, so number is 76. Okay, you discard the negative value of y. Okay, so so the correct answer is 76. This is the last problem for this segment. The problem states like this: a person lived one of his life in city A, then he spent half of the remaining life in city B. The person then lived half of the remaining life in city C, and then spent 11 years in city D before the person died. How many years did he live? So if x is the number of years he lived, then x over 2 was spent in city A. The remaining was x over 2, half of that, so x over 4 was spent in city B. Remaining was x over 4, 1/2 of that is x over 8 was spent in city C. So together 7, 8 over x, and then plus 11 years, that was his length of his life. If we solve, we get x equal to 88 years. Okay, so that's this converting problem statement into a model. In this case, it happens a linear equation. So again, if you have any question, get in touch with us. You have the email address, and we'll come with more material. Okay, bye. Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.